Hello and welcome to today's session on unsupervised learning. I am Dr. Megha Mohammed here to deliver this lecture. My PPT is organized into three sections. Part 1 will talk about clustering and its various types. Part 2 will talk about k-means clustering and proximity measures, while Part 3 will discuss hierarchical clustering. Now, starting with it, first we need to know what is supervised and what is unsupervised learning. Talking about supervised learning, the aim is to learn a mapping from the input to an output whose correct values are provided by a supervisor. For instance, you are attending your classes and your teacher gives you a question to do. Now, while you are solving the question, she is there to help and supervise you as to the right methods of solving that question. That, for you, is supervised learning. On the other hand, when we are talking about unsupervised learning, there is no supervisor and we only have input data. The aim is to find regularities in the input. There is a structure to the input space such that certain patterns occur more often than others, and this is also called density estimation. So basically, we want to find patterns amongst the data. Nobody is going to help us to supervise us to tell us that what are the patterns, what are the data points that are similar to each other, what are the data points that are dissimilar to each other, what are the clusters or the similarity, how to compute it. Nobody is going to tell us here. All that comes under the perspective of unsupervised learning. Now, one method for density estimation is clustering, where the aim is to find clusters or groupings of input. Now, let's talk about what clustering is. Given some instances with data, we group the instances, that is, all these points. Can you see these points in three colors? Now, all these points are instances. Our aim is to group the instances such that instances that are within a group, that is, the intra-cluster distance, should be minimized. That is, instances within a group have to be similar, ought to be similar, while the inter-cluster distances, that is, instances that are in different groups, are different. That means the inter-cluster distance should be maximized. So dissimilar points should be as far up as possible, while the similar point should be as close as possible. That is what is clustering. These groups we have, these groups that we have made, the three groups we obtained here are called clusters. Now, while talking about clustering, the general idea is to partition the instances into clusters or classes. The given data is interpreted to find out natural groups. Now, what are the various applications where clustering is useful? Clustering is useful in biology to find a group of genes that have similar function. Another use is in information retrieval. For example, you search on the web about Amazon. Now, Amazon could be the Amazon shopping site, or there could be an Amazon river. Now, the task, now that is clustering. Clustering together all the results that belong to Amazon shopping site and clustering together all the documents or the result that belong to Amazon river. This is clustering. In information retrieval, we will tend to find a group of related documents. In business, we may want to segment our customers into smaller number of groups for additional analysis. Again, an application of clustering. In image compression, we might want to group pixels in the image with similar colors. So when we group pixels in an image, we may want that similar pixels may be represented in a lower quantity than the others, helping us in data compression. Now, let us talk about the various types of clustering. The first distinction we'll be talking about is partitional clustering versus hierarchical clustering. Now, when we are talking about partitional clustering, it talks about a division of the examples, that is, the data points given to us, into non overlapping subsets or cluster such that each data point or each example is in exactly one data set. If you see in the figure, there are three clusters and each of the data point belongs to only one of the cluster. So this for us is partition clustering. However, when we talk about hierarchical clustering, there is a permission to the clusters to have subclusters, and those clusters may have more subcluster as if it was a tree. So each node, that is, each node in the cluster in the tree, is basically a union of its children, and the root of the tree is the cluster containing all the objects. If you see in the figure here, so this cluster and this cluster both belong to a bigger cluster shown with a green border. Then another cluster with a green border is grouped with this cluster to form another big cluster. This for us is hierarchical clustering. And if you see here that one data point not just belongs to only one cluster. For example, this data point belongs to this cluster with a purple border, this cluster with a green border, and this cluster with a yellow border. So one data point is belonging to more than one cluster as compared to partitional clustering. Now let's talk about partial versus complete clustering. A complete clustering assigns every object to a cluster. However, in some cases, we might not want to cluster all the objects. Now, these cases could be the cases when there are outliers, or there is noise present, or there is an uninteresting background. Then we would not like to do complete clustering, but we would like to go for partial clustering. Because in partial clustering, we only want to cluster some of the data and not all the data. If you see here, all these points are available, and while when we form clusters, there are some data points which have not been clustered into any of the cluster. They do not belong to any of the cluster. So this is an example of partial clustering. Now hard clustering versus soft clustering. In hard clustering, each example is placed definitively in a class. So when I talk about a data point, we know that this data point belongs to this particular cluster. However, in soft clustering, each example has a probability distribution over its class. So it may belong to a point, may belong to a cluster A with a probability of 0.7, may belong to cluster B with a probability of 0.3, and so on. That's all in the first part.